Let us see how to create a table. Now here we are creating a table called employees. So this employees will have some columns or fields. Employee ID is an integer and primary key says that this is the primary key. It will be unique and this is used to search the records of this table and it will auto increment. You don't need to pass it as an ID. Database will take care for you. First name. First name is a character string. So you can give any name here, but limit is 50 and it should not be null. If it is null, then it will complain and it will not insert the record. Last name, same as first name, it has got limit of 50 characters. We should give last name in the limit of 50 characters and it should not be a null. Department, same, it is also a character string of 50, but this can be null because we didn't mention anything called not null here. Salary is a float, is a decimal where you can have 10 numbers in that. 2 could be after the decimal. And hire date is a date. Email is again a varchar character string of 100 limit and it should be unique. You cannot repeat email. If you repeat an email, it will not create the record. And active is a boolean and by default it is true. If you give a value to active, then it will take either true or false. But if you don't give any value, then it is true. Now let us see how to insert a record into employees table. So the syntax is simple, insert into employees. We will list all the fields here, one after the other, which we created for the employees. And if you see here, we are not giving ID because it is auto increment. Table will take care of increasing the ID values. First name is Rajesh, last name Kumar, department IT, salary 75,000, hire date is this one, email Rajesh Kumar example.com, and active is true. So it should be 1:1. Whatever we mentioned here, that value has to be passed here. And this is the example of inserting multiple records at one go. So what we do here, insert into employees and then list all the columns, fields, and then we say values. So this is the first record it is going to create. This would be the second, this would be the third, and this would be the fourth. Let us see how we can update a single record. For example, if you want to update the employees table, whose email is rajesh.kumar@example.com, and we want to update his salary to 95,000, then this is the command. We're going to update employees, setting the salary as 95,000, where email is rajesh.kumar@example.com. If there are multiple records with the same email ID, then it will fail. The insert doesn't work. So there will be only one record with rajesh.kumar@example.com, since we have mentioned email ID as unique in the table. So this update example can update multiple records. The condition here is first name is equal to Meera and last name is equal to Sharma. We can have multiple records with first name Meera and we can also have multiple records with last name Sharma, because these are not unique. They are not nulls. Means we need to have some value, but they may or may not be unique. So here the condition first name Meera and last name Sharma. So those records we will set the salary to 98,000 and their department to IT. So in this example, for example, if you want to give a hike of 5,000 salary for all the employees in department IT, then the condition is department is equal to IT and you are increasing salary with 5,000. So if they have 10,000, it will be 15,000. If it is 5,000, then it will be 10,000. So it will increase 5,000 on the existing salary. So if you want to delete a record whose email is vikram.singh@example.com, then we write delete from employees where email equal to vikram.singh@example.com. So this record will be deleted from the database. Instead, if you want to delete all the employees who are not active. So we have a field active. If we it can have values true or false. If it is true, then employee is active. If it is false, then employees are not active. So we will put a condition saying that the employees who are not active, that is active is equal to false, and then we say delete from the employees table. So all those records will be deleted. Now if we want to retrieve all the records from employees table, then the query would be select star means all from employees. So we are saying select all records from employees. This is a simple query to retrieve everything from employees table without any condition. But instead, if you want to select and see only the first name, last name, department, and salary of the employees, then we have to specifically mention these columns: first name, last name, department, salary, and we say that select that from employees table. If we want to see the details of all the employees whose department is IT, so the condition here is department is equal to IT, and we want to see all the record field values of the table employee. So we say select all from employees where the department is IT. So if we want to see all the employees whose first name starts with P, so if you want to see such kind of employees like Praveen, Pavan, etc., then the condition is first name like. So we are saying like P and then percentage. Percentage is you can have any characters after P. So whatever the name that starts with P from employees table will be selected. The SQL where class. The where class is used to filter rows from a table based on a condition. So we give a condition, and according to that condition, the rows are selected. To simply explain, think of where as a filter in Excel. It shows only the rows that match your criteria. So that's how it filters. And there are some comparison operators that we can use to do this filtering. So what are comparison operators? Comparison operators, they compare values and return either true or false. For example, if you say salary is equal to 60,000, if the employee salary is equal to 60,000, it says true. If it is not, then it gives the false. So whenever the true is resulted, then that row is displayed. So to simply explain, they help SQL decide which rows should be included in the result. If you see here, equal to is one of the comparison operators, where on an employee record, on an employee table, we are putting a condition like salary is equal to 60,000. So if it has got 10 employees, it will go and search all the 10 employees and see whose salary is equal to 60,000. And then only those employee rows are written and shown as a result. And same goes with the greater than operator. Greater than operator we can apply on salary. If you say that where salary is greater than 60,000, then it returns the employees whose salary is greater than 60,000. So all the employees whose salary is less than 60,000, they are not shown up in the results. Even equal to also not shown up because the operator is greater than here. And same goes with the less than, where salary less than 60,000. So it will again filter on the salary where whose employee salary is less than 60,000. It will show only those employees whose salary is less than 60,000, not greater than 60,000, not equal to 60,000. So it will go again, it will go through all the records of the employees, it will search for the salary, and if the salary is less than 60,000, then yes, that employee is displayed. If it is not, then it is not, then that employee is not displayed. And comparate and comparison operator. So here what we do is we take two columns and then we try to do this comparison where department is equal to IT. So we are saying that the employee should belong to IT department and salary is greater than 65,000. So now it goes through all the records of the employees and it will check what is the department of that employee, IT or not. If it is IT, then true. and it also checks whether salary is greater than 65,000 or not. If it is greater than 65,000, then it is a true. Only true conditions will be taken and those employees are shown. So when I say true of department is equal to IT and salary greater than 65,000, if a department is not belonging to IT but salary is greater than 65,000, that record is not shown. That employee will not come up because both the conditions in where clause has to be true if you are putting AND operator. So it returns rows where both conditions are true. Or is different from how AND operates. Here it returns rows where either condition is true. So here if department, if an employee belongs to department IT or a department HR, either ways it will pull the record. It will go to an employee record and will see whether this department belongs, whether this employee department belongs to IT. Okay, he will be in the results or she will be in the results. Again, or if that employee department is HR, yes, then they are in the result as well. So either of the conditions are true, then it is shown in the results. In operator. In operator is an easy version of OR, where you are saying department in IT, HR, or finance. So instead of writing department is equal to IT or department is equal to HR or department is equal to finance, what we are doing here is department in IT, HR, finance. So this is OR operator in between IT, HR, or finance. So it returns rows where the list, where the value matches any value in the list. So if an employee belongs to IT or if an employee belongs to HR or if an employee belongs to finance, they are shown in the result. Like operator. Like operator is used to do a while search. So if, for example, if you see here, like M percentage. If you're putting percentage, any characters that come after M are satisfied in this condition. Whether it is Mark, Muhammad, Manish, anybody can come into the results if their name starts with M. Let us see some examples in PL/SQL developer. So first I will execute. So these are the employees we have, where we have 10 employees who are belonging to some sales department, IT department, HR department, and finance department, and they have different designations to them, and their salary also varies. So now we will see one after the other filter we can apply on where condition and in where clause. So here the first one is all IT department employees. So I just mentioned department is equal to IT and the table is employees. So in employees table, where department is equal to IT, I wanted to get the results. So when I execute this one, you can see that all the IT department related employees are displayed. So this is that simple. And the next one is employees whose salary is above 60,000. Okay, so let us see the whole employee list again. And if you see, there are few people whose salaries are greater than 60,000. So these are all should come up when I execute this query. So the simple query here is you are again selecting from employees and you're saying that whose salary is greater than 60,000. So if you see here the results, everybody's salary is greater than 60,000. And same goes with the less than. So on employees table, again you are putting a condition on salary where it is less than 55,000. So let us try executing this one. Yeah, so these two results that came up has salary less than 55,000. And we can also put equal to here. So it will bring if anybody's salary is 55,000. See here, these two people have 55,000. So after putting equal to, they too appeared as well. So results before equal to is only 2, and after equal to with less than we get 4 records because 2 people, William and Sarah, both have 55,000. And if we don't want a salary per people, per employees whose salary is not 55,000, then if you put less than and greater than, which is equal to, less than means not equal to, right? So if I execute this, it should bring up all the employees whose salary is not 55,000. See, if you see here, nobody is there whose salary is 55,000. But we know that there are people who has 55,000, right? Let's see who are those. See these two people. These two people didn't come up when I did this operation. It is not equal to 55,000. And this can be achieved in this way as well. Not equal to. Right? So not equal to, greater than or less than, are both same. So now let us see uh, whose department is IT and salary is above 65,000. So we have two conditions here. First condition is their department should be IT, and second condition is salary should be greater than 65,000. If these both conditions are true, then only we will see the results. So if you see here, department is IT, yes, true. And salary is greater than 65,000, yes. That's the reason these two results came up. That's how AND operates. And let us see how OR operates. This is the employees table. We are saying that bring in employees whose department is HR or department is finance. So we should see both the department people here, HR and finance. Looks like we don't have any finance department. That's why we didn't get anybody here. Let's see any other department. Did I spell it wrong? Yeah. So case, lowercase and uppercase formula. Yeah. So here, yeah, case should match. If you see here, my condition is the department should be HR or department should be finance. So it went through all the records, and whoever satisfies whether it's a department HR or finance are pulled up here and the results are shown. This is how OR operates. And in is a easier version in writing, but it acts exactly like OR. So instead of writing department is equal to HR, department is equal to finance, department is equal to IT, or department is equal to sales, what we can do is just we can list those departments here and say if this employee falls into any of this department, then bring those employees. So if you see here, IT, HR, sales, it looks like there are no employees in capital sales. So let's see here. Yeah, see, we got IT people here, HR people here, and finance employees here. So that's how in operates. In and OR are similar in nature but different in syntax. Okay, and then I want to search all the people whose name starts with capital J. John, Jane, Jennifer, right? That's good. Let us try something else. Again, same. And we see. So here, what we are saying here is anything that's come, any characters that come before A and any characters that come after A, bring those employees. So in Williams, we have A here. All these characters are before A and after A. After A, we have M. Same way, A and before and after A. So all these conditions satisfied. Even if there are no characters, it will bring up like Linda. Okay, so this means any number of characters or no characters as well. So that's how like operator works. So you use like, and then if you don't use percentage, it still works. But the major purpose of using like is where you use this percentage operator to search with. So if you are using like but you don't use any percentage operator, it becomes equal to. It is same as equal to in that case. Okay, and let us see all possible operators in these where conditions. Okay, so by now you might have understood how these operators work. So it says salary is greater than or equal to 50,000. So it will pick if employees whose salary is greater than or equal to 50,000 and salary is less than or equal to 80,000. So now it puts a condition. It should employee's salary should be greater than or equal to 50,000 and less than or equal to 80,000. That means all the employees whose salaries falls in between 50,000 and 80,000 and equal to 50,000 and 80,000, will be part of this search. And there is another condition here, their department should not be finance. And next condition is department should be, or they may belong to IT or HR or sales, but they should not belong to finance. That's what this and condition says. And employee name should start with J. This is another condition. So these are all and conditions, means everything has to be true. And their hire date should fall in between 2020 2023. So these are the hire dates. And their designation should not be null. That means they should have a designation. Let us run and see how this query works. So with all this criteria, we have only one person, that is John. And we can see if there are any people who are not really starting with J. Yeah, there is Mary and David. If you see here, Mary department is HR, falls in HR. And Mary's salary is 50,000, equal to 50,000. Yeah, equal to 50,000. And less than 80,000, yes, satisfies. And then higher date is from 20 to 2020 to 2024 approximately. So yeah, she's in 2021. So that is also good. And there is a designation. So that's how we can use combination of operators and get the results. So this is how where class operates, and this is what the filtering is. What are aggregate functions? Aggregate functions perform calculations on multiple rows and return a single result. So simply to explain, they summarize data. For example, if you want to find how many number of employees are there, then what we do is we will select from employees table and we say count of star. When we say count of star, it goes through all the employee records and it will make a count of them and it will display that it is 5. So the number of employees in that table are 5, that is count. And if you want to know, for example, there are 10 employees and you want to know the sum of all the employees, right? So how much you are paying to all the employees. There are 10 employees working in a company and owner wants to know how much salary he is paying to all his employees. Then the equation is select sum of salary from employees. So what you're saying, you're saying that go to employees table and sum all the values in the salary column. So it goes there. There are 5 records and each of them have like 60,000, 50,000, 70,000, 55,000, 80,000. So it's adding up all these things and it says total of all salaries. And what is average? So now you want to know how much average salary you're paying as a company. So then what it does is it will first sum up all the salaries and then it divides by the count of records. So 3,15,000, 15,000 is divided by 5 and then we get the salary, average salary is 63,000 for that company. And for example, you want to know what is the maximum salary you are paying. So you want to know to if you're paying any employee maximum salary, what is that? So it returns the highest value in the table, which is, if you see here, 80,000. So the highest is coming, and the same way minimum, that is the returns the lowest value. Minimum is, we can see here, 50,000. So this is like on a table you are working on multiple rows. In a table you're working on multiple rows to get a single value. That's the reason it is called aggregate. So it is a aggregate function. It works on whole table. It doesn't work on a single record. It works on multiple records in a single table, and it will bring us the values. Let us see something in practical. Okay, so let me fire this one to understand how many employees there in the employee table. So we have 10 employees. Okay, let us see. Yeah, you see here we have 10 records. So instead of running through all the records and see how many employees are there, we just fire count of star and it gives, okay, these are the number of employees in your organization. And if you want to see how many people are there in a certain department, so right, so if you see, we have different departments. if I run this query, you can see people from different departments, but I don't want to know everybody now. I want to know how many people belong to IT department. So what I do is I say select count from employees. I'm counting from employees, but one condition, that is department is equal to IT. Now let us fire this query and see. 3 people are part of IT department. Let us see for whole employees table. Yeah, one. We have John, we have David, and we have Mike belongs to IT. So that's the reason we are saying 3 as the count. And next one is salary. What is the sum of the salaries we are paying for the employees? The owner is correct. So which is equal to 61,000. So it is adding up all the records summary. It is adding up all the salaries here, and that is what it is giving us sum. And average is by 10 of what we got for the sum. So it summed up all the salaries and then it divided by the count of employees. So that's how the average has come up. Okay, and let us see what is the maximum salary. Maximum salary is 80,000. Let us see that here. See here, the maximum is 80,000. And what is the minimum? 45,000. Let us see by firing the minimum salary now. Yeah, it is 45,000. So if you see these aggregate functions, min, max, average, sum, count, these are operating on the table, okay, and all records of the table, not on a single record of the table. That is the reason these are all called aggregate functions. Today's video, we are going to learn Oracle SQL joins, one of the most important concepts in databases. By the end of this video, you will understand inner join, left join, right join, full join, and self join. So let's get started. What are joins? In Oracle SQL, a join is used to combine rows from 2 or more tables based on related columns. Most commonly, we use a foreign key to connect tables. For example, employees and departments. Imagine employees table has department ID and departments table has an ID. Using join, we can show employee details along with their department names. Let us see how we can do that. So if you see here, we have 2 tables. First one is employees, where we have 4 records for employees, and we have 2 departments. If you see here, department ID 1 and department ID 2. And let me stick this one. If I run departments, there are 2 departments. First one is computers, second one is electronics. So if you see here, Amar and Ajit points to department ID 1, which is computers, and Ravinder and Raju, they both map to department 2, which is electronics. So now if I have to run a join on these 2 tables where a department ID is 1, so literally I am pulling the employees whose department ID is 1. For that, I am selecting the name of the employee and department name. So to join, we need 2 tables. That is, first one is employees table, and then I am joining it with the departments. And I am saying that department ID and employee department ID should be same, and department ID is equal to 1. Here if you see, department ID 1 is equal to computers. So we want to see the people who are the employees who are part of computers department. So if you run this query, as expected, Amar and Ajit came up because Amar belongs to department 1 and Ajit belongs to department 1, whereas department 1 is computers. So both of them come. So this one is called an inner join, and inner join will join the tables perfectly on the condition. So it doesn't give anything else. whatever it satisfies the condition. First condition is department ID in departments and department ID in employee table, both should match, and then department ID should be equal to 1, which is computers. So inner join returns only the matching rows between two tables. So the one keyword matching rows for inner join. You can also write inner join inner here. The result would be same. Inner we can take it out as well. It will be treated as inner join only. Now what is left join? Left join returns all rows from the left table and matched rows from the right table. So it brings all the rows from the left table and matched rows from the right table. That is called left join. Let us see our example. So for the left join, we are selecting the first name, department name as usual, and then from employees we are joining the department as a left join. Whereas earlier we had it as a right join, just join. Now we are doing it as a left join, and then the matching condition here will be department ID is equal to employee department ID. So only difference here is left join, and I remove the constraint of only department 1. Users to be right. So if you see here, first we will see what employees table has got. Employees table has got one more extra row while compared to the previous one, Ram Yadav, whose department ID is 3. And then here we have first department ID 1 computers, department ID 2 electronics. We don't have any department 3 here. Okay, so let us see what this left join will bring. So it brings Amar computers, Ajit computers, Ravinder electronics, Raju electronics. These are all good because they are mapped to those departments. Since we don't have any department with ID 3, this left join, what it does is it pulls the record from employees table, and employees table record is Ram, and department name it will mention it as null. So this is what left join does. What is a right join? Right join returns all rows from the right table and only matched rows from the left. So if you see here, it brings all the rows of right table, but it only brings the matched rows of left one. So that is right join. And let us go to our So let us see the tables again. Employees table. We have Amar, Rajit, Ravinder, Raju, Ram, same as the previous one. And whereas departments, we have an extra department now, mechanical. Just to demonstrate how right join works, I have inserted department 21, where this 21 department doesn't have any employees here. Okay, so when we run this right join here, this is the same format. First name and department. From employees, we are saying right join the departments. So right join the department, this is the right table, this is the left table. So now it brings everything from departments. It brings mechanical, electronics, computers, all the 3 departments it brought. It has a matched employee for electronics and computers. So it brought Amar, Ajit, Ravinder, Raju, respective departments. Since there is no matching record for mechanical department in employees, it brought null. So that's how right join works. What is a full outer join? Full join returns all rows from both tables, left table and right table, matched or unmatched. So if you see here, it brings all the records from left and all the records from right, and it brings the matched ones. These are the unmatched ones. These are the matched ones. So everything it brings. Let us see our example. Okay. So employee table is as is. We didn't change anything here. And department table is as is. We didn't change anything here. So we have a department which doesn't have an employee, and in the same way we have employee who doesn't have a department in department table. So now let us execute this one. with full join. Same thing, just we replace it right with full here. The conditions stays same, department ID and employee department ID. If I run this query, you see here, Amar has a matching department. So Amar had computers that matched there. Ajit also matched with computers. Ravinder has department 2, which is electronics. Raju has a department 2, which is electronics. Ram has a department which is not there in department table. So that's the reason it gave null. And mechanical department doesn't have an employee. So that's the reason it gave null here. So it is a combination of both left and right join. It gives everything matched and unmatched. What is self join? A self join means joining a table with itself. For example, an employees table where each employee has a manager. Let us see our employees table now. I have added a column manager and I have added 21, which is Ram as manager for Amar and for Ajit as well. For Ravinder, Amar is the manager is 1, Amar, and Raju again 1, which is Amar. So how to use our self join to get this? So here I'm joining with employees with employee. I'm saying it as a left join because I want all the details whether a manager is existing or not. Click here. If you see here, Ravinder has got Amar, Raju Amar, Amar has Ram, Ajit has Ram, and Ram doesn't have a manager. Since I added it as left join, Ram came up here. Otherwise, Ram doesn't come. Okay, so here what we did. So what we did is we joined employee with employee. Employee E and employees M. Both are employee table only, and we just put a condition that ID of an employee is manager. Then bring it as a manager for the corresponding employee. So this is how it comes. So this helps create hierarchy structures like employee manager relationships. Group by. The group by class groups rows with the same value together. So it divides data into groups. So aggregate functions can be calculated for each group separately. Let us see how it works. It first divides the rows into groups. For example, if you see in this table for employees, it is grouping on IT. So it has sorted on IT and it made a group of IT here and it kept it as a IT group. And then for HR is the same way it grouped and it put as a HR group here and for sales as well. So we are grouping here on department. It sorted employee table first and then it put IT into IT bucket, HR into HR bucket and sales into sales bucket. Once that is done, our operation is to average the salary. So the average salary doesn't work on complete table here. Since we are doing the group by, it works on the individual groups, department, IT group, HR group and sales group, and it averages these two for IT and it gives 65,000 and it averaged for HR 50,000 and 55,000 and 52,500 here, and in the same for sales. So the average works on the groups, not on the whole table. So this is how group by works, and it generally works on aggregate functions where you will have calculating averages or count, minimum, maximum, whatever we saw in the previous video. And there is an important rule of group by. Every selected column must be part of the group by. So if you are using department here, if department is in the group by, then only we can have the department in select. If you try to put employee ID or something, then that value will repeat. For example, in IT we have two employees who has 60,000 and 70,000. If we want to show here, we have to show employee ID 1, employee ID 2. So we avoid that. So that's the reason the select, whatever we put in select should be part of group by. Or it should be part of the aggregate function. So either it should be part of group by or it should be part of the aggregate function. So that's how it works. Let us see some of the examples. So let us run our query where I am ordering on department and designation. This has ordered on department first and designation second. So if you see here, finance are all ordered first, HR is ordered next, IT, and then sales. Now, if we apply a group by, what it does is, it will take these two salaries, since it is an average of salary, it will group by finance, and then it averages 58,000 and 75,000 and takes the average of these two salaries and put it to the finance. Same way it does for HR, IT, and sales. Let us run this query and see. What I am trying to do here is, I am grouping by department and it is in my select. Salary I am averaging, so it's part of aggregate function. Let's run this query and see. See here, it has grouped into sales, IT, HR, and finance, and it took the salaries in sales department and averaged it. And same with IT, HR, and finance. So this is how the group by works. Let us see the total salary by department. Now this is just average, right? So instead of having average here, we are putting sum. And if you see, the group by is again department, and salary, since we are operating aggregate function on salary, we can have salary here. And then if I run it, it will calculate the overall salary of sales department, IT department, HR department, and finance department. So if we don't include group by here and then run this one, then the sum and remove department, the sum salary will give salary sum of the all salaries in the table. But this is useful when you want to know sum of salaries for individual departments. So that's how group by will be useful. And in the same way, we can get the max salary as well. It doesn't change anything here. Only in place of sum, we are taking max, and it gives the max salary in the department. That's how max salary by department runs. And now we want to know the count of employees who are there in the department, each department. So in sales, it says three people are there, and in ID, we have 3, HR 2, and finance 2. We can go and cross check that too. See, sales 3, IT 3, HR 2, and finance 2. Okay, so that's how it works. And if now we ran this query and we understood that it gives count by department. But if I am interested in knowing how many departments have more than 2 people in that department, so my question will filter out this HR and finance. But how to achieve that one? We cannot use where here, because where runs on the rows, not on the grouped by sets. So for that one, we need to use having. What is having? The having class filters groups created by group by. So where filters on rows, having filters on groups. So let us see how having works. Select department count of as employee count from employees, group by department where count is greater than 2. That's what we try to do here. So if I remove this having here, it gives all departments and its count. But I want to know only those departments whose count are more than 2. So that's the reason I am applying having here. So having works on group by. The column whatever we selected, the field whatever we selected in the group by, on that having works with this aggregate function. So if you see here, so it worked on the count of department. That's how it works. Now let us say departments with average salary greater than 60,000. So you can have any operator on it. We saw it, all the comparison operators earlier, right? So we can have any operators, and then we can run the having by. So having will be always on the aggregate function, whatever we have applied, and it results on the group by column. Yeah. So whatever is greater than 60,000, it has bring in. Let us see if we have any which are less than 60,000. Yeah. And if we don't use this having here, then we will get the combination of both greater than, equal to, and less than. Right? There is no equal to, so we got that. So that's how having works. Right? And then we can also have the summary salaries, total sum of salary, and we can do the having on sum of salary whose salary is greater than. So you can apply in many ways. Having can be used on this aggregate function on salary, which we are working on, and then it works on the department group. So that's how it works. And we can also have multiple aggregate functions working on the same group by column at the same time. So we can have count of star along with sum of the salary. I am asking to get count of employees. It works perfectly because department is part of department, and here sum is aggregate function we can have, and count is an aggregate function we can have. But we cannot have employee ID here. We cannot have employee ID here. If we put employee ID here, then it will not allow. We'll see why. Right? Because employee ID will resolve into multiple. If you see in this query, when I am grouping with department, if I am averaging the salary, it is taking two of them and averaging it. If I am counting, then it is taking 108 and 109 and saying 2. But if I ask for employee ID, it has to take 108 and 109 and show it as a list. Then that would be same as select star from employees. So that is same results. So that's the reason it will not show. It cannot show multiple records for the same group. But here, if you select employee ID, that's what's going to happen. You have to show 108 and 109 in individual rows. But group by works on single row. Right? It gives you one row for one group. That's the reason it doesn't work on this way. But if you want employee ID as well, then you can do this way. Employee ID, and you can add it in the. Now it is allowed because you have it group, so it will group on department and employee ID combination, and it works. Let's take comma here. See, it works like that. Now, if you see groups are formed in combination of IT and employee ID. Earlier we saw only IT department coming once, right? But here it came twice because it has two employees. So that's how it works. So according to your requirement, you can use group by and having.